How are you guys doing today? What I wanted to do today was to create a video on a coding interview assignment I was asked to complete during an interview. Here's what they wanted me to do. They wanted me to implement a function that returns the nth number in a Fibonacci sequence. So the first thing I had to do was break down the problem. As you can see on the screen, there's a chart. This chart is divided up into two sections. One section will be n, which represents a number, and another section is fib of n, which represents the Fibonacci number. So when it comes to the Fibonacci sequence, the current number of the fib sequence will be equal to the sum of the previous two numbers. But there are two base cases. If the number entered in is 1, the Fibonacci number is 1. And if the number entered in is 2, the Fibonacci number is 1. But let's just say we enter in 3. If we enter in 3, we have to add the previous two Fibonacci numbers together in order to get that current Fibonacci number. So, next thing I had to do was create a formula. So let's just say, for example, we have the same chart, but we do not know what the Fibonacci number of 4 is. How will we go about doing that? The first thing we need to do is create a formula. Now, with this formula, let's just say we're looking for the Fibonacci number of 4. We'll pass in 4, and we get Fibonacci 4 equals Fibonacci 4 minus 1 plus Fibonacci 4 minus 2, which pretty much states that the current Fibonacci number is going to be equal to the sum of the previous two numbers. So we then simplify this. We then get Fibonacci 4 equals Fibonacci 3 plus Fibonacci 2. We already know what Fibonacci 3 is, and we also know what Fibonacci 2 is if we just look at the chart. Fibonacci 3 is going to be equal to 2. Fibonacci 2 is going to be equal to 1. So we add these two values together, and we ultimately get Fibonacci 4 equals to 3. So let's get to the code now. The first thing that I want to do is write a function. This function is going to return a number. And the function will also take in a number. Now, when I put together the method, the first thing I want to do is check for the base cases. Now, as I stated in my presentation, there are two base cases, 1 and 2. So what I want to do is add a conditional statement that says if n is lesser than or equal to 2, then I want to return 1. So if n is lesser than or equal to 2, then I want to return 1. Now, I also want to write an else condition. And this else condition is going to contain the actual formula for calculating the Fibonacci number based on the given number. So you want to return fib n minus 1 plus fib n minus 2. Let's save this. And basically what we have here is a recursive method that is going to invoke a method call upon itself until it comes up with the Fibonacci number that we're looking for. So what we want to do, we're going to go up to this main method and print the value of this method out. Let's just say fib of 4. So if we do this correctly, this is what we should get. Fib of 4 is supposed to return 3. We entered in 4. This is our formula that we have. And now we just simply run the application. We have 3, exactly what we wanted. During the interview, after implementing the function, I was then asked, what are some problems with the function that I've written? My mind went blank, and I didn't know how to respond. After doing some research, I learned there were 3 things I needed to take note of after writing the function. The first thing, checking for numbers below 1. Now, let's go back to the code. Now, the reason I want to check for numbers below 1 is because when it comes to a Fibonacci sequence, there's no Fibonacci number associated with numbers that are negative or any numbers that are lesser than 1. So, how I'm going to fix that is by writing an if condition. If n is lesser than 1, then what I want to do is throw a new illegal argument exception. And just write no numbers or just numbers below 1 not allowed. Let's just write it like that. Numbers below 1 not allowed. And if I'm checking for this condition below 1, I also have to change this conditional here so that they don't conflict. So if n is equal to 1 or n is equal to 2, then I want to return 1. So from here, in this condition, I'm checking for these numbers specifically. Now, let's just enter in a number below 1. Let's just say -5. Save. Now we run the application. And we get the illegal argument exception that we were expecting. Numbers below 1 not allowed. Alright, so another thing that I had to take note of was the number of recursive calls for large numbers. So that pretty much means if you enter in a very large number, you're eventually going to get a stack overflow exception, especially if the function is, well, if the function has a recursive call, you're going to get a stack overflow. So let's try this out in the code. So let's just say up here, we enter in 10,000. We enter in 10,000, we save it, and then we run the application. It's going to take a while for this application to produce a result. But due to the fact that the number of recursive calls grows exponentially, it's going to eventually lead to a Stack Overflow exception. So we're going to stop this application, and I'm going to come back to this and show you how to resolve that. Let's go back to the presentation. And another thing you have to take note of is the time complexity. So as I said before, if there's a number of recursive calls, the function is going to grow exponentially. And there's a way to resolve that so that the function can have a time complexity, a linear time complexity. So I'm going to try to show you how to do that now. All right. So the first thing we want to do, we want to create another function. And we're going to name this function fib non-recursive. It's also going to take in an integer. And we want to set this up kind of similar to the way that we set up the first function. So I'm going to add me a conditional statement. If n is lesser than or equal to 2, then I want to return 1. Next thing I want to do is add 3 variables. first, int second, and int nth. Now these three variables are going to be used in order to calculate the next number, or the number of a Fibonacci sequence based on a given number. So we want to set this first variable equal to 1. We want to set this second variable equal to 2, and we want to set this nth variable equal to 2 as well. Now, what we want to do next is write a for loop. In this for loop, we're going to have int I equals, and we want to start this at 3. Now the reason that we're starting at 3 is because we've already handled the base case of 2 here. So I just want to start off with 3 right here. That's what we're going to be doing. Now if I is lesser than or equal to n minus 1, then I plus plus. So basically, if you enter in a number here, it's going to check this number within this range, between 3 and the number that's passed in. So the first thing I want to do is say, or write nth equals first plus second. First equals second, and second equals nth. And I want to return nth. Now, what's going on here? This nth variable is going to be the variable that calculates the Fibonacci number. So you're going to add the first and the second, and that's ultimately going to give you the number that you're looking for. So this nth value is going to be based on the number of iterations as well as the current number of the first and the second number. So you'll also realize that this fib non-recursive method is going to be able to handle this 10,000 right here, because there are no recursive calls. There's just a simple loop which iterates a certain number of times based on the number that's passed in order to eventually spit out the Fibonacci number. So if I were to call this method and then pass in 10,000, here's what we get. The Fibonacci number of 10,000. There's no stack overflows. The time complexity of this is n, which is a way better time complexity than an exponential time complexity. And to explain this a little bit further, I actually want to go back to this presentation that I have. So for this non-recursive method, this is how it works. So for this non-recursive method, as I said before, the first is going to be equal to 1, the second is going to be equal to 2, and the nth is going to be equal to 2. Now, what I'm doing here is I'm starting at 3 because I've already handled that case for 2 up in that first if condition. Now, the best way to explain this is by using an example. So let's just say I pass in the number 4. So due to the fact that I start at 3, there's only going to be one iteration since I'm passing in 4. So in this first iteration, n, the nth variable is going to be set equal to 1 plus 2. First plus second. First plus second, which you can see here. Nth equals first plus second. Now the first is going to be set equal to 2. And the second is going to be set equal to nth, which is 3. And fib of 4 will be equal to nth. See? And then we're returning nth, which will ultimately be 3. And if you were to enter in another number, let's just say you entered in 5, you would have to loop through this twice instead of only once. If you have any questions, leave them in the comments below. Don't forget to subscribe and like the video if you found it helpful. I'm actually thinking about creating a channel that is specifically dedicated to coding interview questions like this one. If you think I should do that, leave it in the comments below. Until next time, thanks for watching.